Good day, ladies and gentlemen. Just kidding. Okay, what's up, you beautiful intellectual souls? Okay, I've got another mechanics video for you. And this one's a big question. And it asks every single year. And this is basically guaranteed marks for you. And I've extracted it. It's cool. I'm calling it the differential / integral motion question. And it leads on very nicely from our previous question on kinematics. And it's basically getting you to use differentiation, and integration to solve motions questions. And we'll go through two really good examples in this video, but I've got all of the questions. It's a really big one. It's quite a lot of marks. And so, let's get this one right. And so I've got all the questions from 2020, 2021, and 2022 on this worksheet. And I've answered them all for you. I've answered them all. It's 43 pages long. I mean, what more do you want from me? So I've answered them all for you, so I'll put a link to download that in the description. And all you need to know for this question is velocity is the rate of change of displacement, and acceleration is the rate of change in velocity. And obviously you can go back and forth. So if you want to go find the displacement, where you integrate velocity, and if you want to find the velocity, where you integrate acceleration. It's just going back and forth between the two. You should have learned how to do basic differentiation and integration in your Pure 1. You can watch my videos on that. I have an integration and differentiation video for Pure 1, which you can watch. But that's all you need to know, is this. That's it. And you can go to the questions. I don't think I need to go through this. The questions will help you understand this, but, it makes sense. Velocity is the rate of change in distance or displacement. Displacement is just distance with the direction, and acceleration is the rate of change in velocity. Something you already know. And if you want to go back and forth, well, you just integrate, because integration is the opposite of differentiation. So all we're going to do here is we're going to go through two really good questions, get you a good feel for this, and then after that I will discuss some powerful ideas they present here. Right, let's just jump right into it. I'm so pumped. I know you are too. Give yourself get pumped, Okay, a particle, so this is how it always goes, like a particle P moves in a straight line from a point 0 and comes to rest 14 seconds later. So we know, so just start jotting down what they're asking, what they're giving you. So velocity is 0 when time is 14. At time t after leaving O, the velocity of P is given by this. So we're given that. So they can ask it like this, where they have these split functions. So, the function takes a certain form, between 0 and 6, it's a parabola. And then between 6 and 14, it's a straight line. So they can ask it like this. Is pt squared minus qt. And that's the motion of the particle between the times 0 and 6, and v equals 63 minus 4.5t between 6 and 14. Okay, where p and q are positive constants, so p and q are positive constants. The accelerations is another thing they're giving you. The acceleration is 0 when t equals 2. Given that there is no instantaneous changes in velocity, find P and Q. What does it mean by no instantaneous changes in velocity? Well, that means that, it just doesn't jump from like 3 to 90. It doesn't do big jumps. So that means, it's continuous. So what that tells us is, the velocity here, when we're changing between these two sort of shapes of its motion, the velocity of this part at 6 will equal the velocity of this part at 6. That's what it means. There's no instantaneous change. It doesn't just jump from one value to another. So we can say that obviously if we want to find two unknowns, we need to set up two equations relating those two unknowns, and then we can find them. So the first way to first find the equation relating the two will be to say, well, as no instantaneous instantaneous change in v, we can say that the velocity, so when t equals 6, sorry, well, v will equal to 63 minus 4.5 times 6, which equals 36. So that means, because there's no instantaneous change in velocity along this motion, that means that then at t equals 6, this will also equal 6, you know? I mean, this will equal 36, sorry. So that means that 36 equals to p of 6 squared minus q of 6. Okay? So let's divide through by 6. We get 6 equals to 6. 6 equals to 6p minus q. So that's one equation relating p and q. And how are we going to find another one? Well, we know that the acceleration is equal to 0 when t equals to 2. You might think, well, why don't we just plug this point in to here, and we could get not here, into here to get another equation relating p and q. Well, we can't do that because this velocity equals 0 when t equals 14, which is where the motion of the particle takes on this velocity time equation. So you can't just plug this into here because it doesn't, the velocity equals 0 and time equals 14 doesn't apply because, you know, this is only between 0 and 6. But this is at time equals 2, so we find the acceleration for this part, then we can plug this in and get another equation relating p and q. Well, so as v equals to pt squared minus qt, pt squared minus qt, well, dv by dt is equal to the acceleration. So the acceleration is the rate of change in velocity, or the differential velocity, and this equals to d by dt of v, which is this. And from basic differentiation, this will be 2pt minus q. So therefore, the acceleration of this particle between time 0 and 6 is going to be 2pt minus q. You know, between 0 and 6. And we know that the acceleration equals 0 when t equals 2. So therefore we get 0 equals 2p times 2 minus q. So therefore we get 4, let's do it like this. We get q equals to 4p. That's a second equation relating q and p. So now we can find q and p by just substituting one of the equations into the other. So let's substitute 2 into 1. Well, 2 is 6 equals 6p minus q, and our q is 4p. So that gives us 6 equals to 2p. So therefore, p equals to 3. Okay, and so then we can find q. So therefore, q equals to 3 equals to 4 times 3. Substituting into here, which equals to 12. So q equals 12. So we found our p and q. So important there to understand what this means. That's why we could find this first equation. Okay, so sketch the velocity time graph. So 3 marks. Okay, B. Okay, so let's rewrite it. So we have V equals, well now we know P and Q is, so it's 3t squared minus, what was Q? What was, so 3t squared minus 12t. Minus 12t. So just rewrite it to get an idea between t and 6. And we also have that V equals to minus 4.5t plus 63. Minus 4.5t plus 63. And this is between 6 and 14. Okay, so let's get an idea of what these look like. Well, for this first one here, so for this one, well, this is a parabola, right? And so let's just get some key points here. Well, you know, when v equals 0, we get that 0 equals to, maybe I'll do it down here. So, you know, we're trying to just get an idea of what these two sections look like, and then we can sketch the overall thing. So when v equals 0, we get that 0 equals 3t squared minus 12t. Factor out 3t gives us t minus 4. So, you know, v equals 0 when t equals 0 and t equals 4. So that means it passes through the points here, this parabola, 4 and 0. So it's like that. It's going to look like that and pass through the points 0 and 4. Let's also find this bottom point here and also find this top point here. So we get a good idea. So this bottom point will occur when t equals 2, right? Halfway between 0 and 4. Or when t equals 2, v equals, so I'm just getting an idea. 2 squared minus 12 times 2 is minus 12. So, you know, this comes down to minus 12. And then what about when it equals 6? I think that might be an important point. I'm just getting an idea here. When it equals 6, v equals 2. V equals 2. 3 times 6 squared minus 12, 6. 36. So it rises here to 36. This is VT. So it's going to look something roughly like this. Okay, and then the next part will be, this is just like a straight line, right? Obviously at 6 it'll equal 36. So here, and then it goes all the way to 14. And at 14, so when t equals 14, v will equal to, and this is just a straight line with a negative gradient. So minus 4.5 times 14 plus 63. So v will equal to 0. So it's going to look like that. So this part here. So let's just sketch it nicer. I'm not going to do it too well because you'll get the idea. So we have this thing. So let's say this is 4, this is 2, this is negative 12, and this is 36. You could do it better than this, but I'm just trying to save time. So this thing, and let's say this is 6 here. So this thing will sort of go, start from here. It'll go down. It'll go down to 12 and up to 36 roughly. And then let's say this is 14. Well, then it will come down here with a straight line to 14. So that's 14. Apology for the bad drawing, but you get the idea. So this is the v equals minus 4.5 t plus 63. And this part here is the v equals 3t squared minus 12t. Right, and it acts from 0 to 6, and this one acts from 6 to 14. See. Bad sketch, but you know, you get the idea. Find the total distance traveled by p during the 14 seconds. Oh. Okay. So the total distance, so distance total, will be this distance here, right? Plus this distance here. So it would be, we could call these, we could split this up into 3 sections. You know, this is, let's say, distance 1 plus distance 2 plus distance 3. And we can find these through the displacement. So because we know, so let's just rewrite our thing, velocity equals 3t squared minus 12t. And this is for this. And v equals 2 minus 4.5t plus 63 between 6 and 14. So therefore we can say, you know, ds by dt for this part here will equal to 3t squared minus 12, right? Because this equals ds by dt. So therefore, you know, ds equals, if you want to be super pedantic about it, times dt, and then you integrate both sides. And that becomes s, and this becomes this. Okay? Now you might think, well, why don't we just calculate from 6 to 0? We can't do that because this is displacement, and this here, the displacement will be negative, and between here and here, the displacement will be positive. That's why we have to split it up into 3 different areas. So, you know, if we were to calculate the area under the graph between 0 and 6, well, these two are going to minus each other out, and we actually won't know what these areas are, but rather the sum of these two areas. And this will be a negative and positive, so they'll kind of cancel each other out in a weird way. So what we can say is S1, so this part here, displacement here, will be between 4 and 0. And so what does that equal? Well, this is going to be 3t3, so I'm integrating over 3 minus 12t squared over 2 between 4 and 0. So therefore S1 will equal to, simplify this a little bit more, minus 6t squared between 4 and 0. And that equals to 4 cubed minus 6, 4 squared. That equals to minus 32 minus, I'm going to 0 be 0. So this is equal to minus 32. That makes sense, right? So the displacement here is minus 32. So therefore the distance here, so d1 will be 32 meters. And then for S2, well, this is going to be the same thing, but between 6 and 4. So this area here, 6 and 4 of 3t squared minus 12t dt, which equals to this, t cubed minus 6t squared between 6 and 4. So therefore S2 equals to 6 cubed minus 6 cubed, right? So it's going to be 0. And the 4 we already found was minus 32, so it's minus 32. So this is positive 32. So therefore D2 equals 32 meters. And finally S3, which is this part here between 6 and 4. Well, now we have a new VT line. So S3 is equal to the integral between 14 and 6 of minus 4.5t plus 63 dt. Again, this thing is calculated like, you know, v, if v equals this plus 63, well then this is ds by dt equals minus 4.5t plus 63 times through by dt gives us that. And then when we integrate both sides, this is s, and we get that, and that's where this comes from. Need a bit more space. So this equals to minus 4.5 t squared over 2 plus 63t between 14 and 6. Therefore S3 equals to minus 4.5 divided by 2. I want that as a fraction, so it's minus 9 over 4 t squared plus 63t between 14 and 6, which equals 2. That times 14, so then you just plug in the values. Plus 63 times 14 is 441 minus, when it's 6, you get minus 9 over 4 times 6 squared plus 63, 6 So minus 297. So that equals 441 minus answer. It's 144. So D3 equals 144 meters, and therefore the total distance will equal to 36 plus 36 plus 144, which equals 2 plus 36 plus 36. 144. 441 minus 297. 6 plus 36. 216 meters. I feel like I got a different answer here. Let me just check real quick. So this was question 10 from the worksheet. Might have made a little error. 312, 32, 32. Oh, I just calculated it wrong here. Oh, 36. I got 36 instead of 32. Why did I get... Oh, why did I say 36? What am I doing? Sorry about that. So 32 plus 32 plus 144. 208. See, always trust my answers. Okay, so that's the answer. Okay, and now we're going to do another one. Right. Okay. So that was doing one with different sort of where it's changing the motion. So you've got a certain way the particle is moving. In one section it was between 0 and 6, and in the next section between 6 and 14 it was moving in a different way. This is just, a constant. It's the same function the whole way through. So a particle P moves in a straight line from rest at a point O on the line. So from rest, so at t equals 0. So write out what they give you. T equals 0, V equals 0. At t 0, the acceleration is, so we have acceleration equals to k, 16 minus t squared, where k is a positive constant. And the displacement from O is s. The velocity of p is 8 when t equals 8. So when t equals 8, v equals to 4a. Show that s, so the displacement is 1 over 64 t squared 96 minus t squared. Okay, this is a good one because you're going to have to go from acceleration to velocity and then velocity to displacement. Okay, so we have this, so that means that dv by dt equals to k times 16 minus t squared. So just remembering these points as well. So therefore, we get dv equals to k of 16 minus t squared dt. And then if we integrate both sides, we get v equals to k of 16 minus t squared dt, which equals to 16t minus t, go up by power, so 1/3 t cubed plus, so it'll be that times k plus c. So therefore we have that v equals, so that k times 16t minus 1/3 t cubed plus c. Okay, and now we need to find these c and k. We know that the velocity is 0 when t equals 0. So when velocity is 0, this whole thing, t equals 0. So that means that, 0 will be k, and this will be 0, right? 0 and 0 plus c. So therefore c equals 0. And what is k? Well, we know that at t equals when t equals 4, Oh, I'm making a lot of mistakes today, boys and girls. T equals 4, V equals 8. T equals 4, V equals 8. So we can find then K. So we have that V equals K. T minus a third T cubed. C is 0, so we have this. So what is K? Well, 8 equals to K times 16 times 4 minus a third, 4 cubed. Hopefully it's useful for me to go through some of these. And so therefore we get 8 equals to 4 cubed divided by 3 plus 16, 4. So this equals to K times 128 over 3. If we rearrange for K, do 8 divided by that. This gives us K equals 3 over 16. So we're getting closer. So now we have the velocity equals to, for this particle, equals to K, which is 3 over 16 times 16t minus 1 over 3t cubed. Okay, so we have a equation for V in terms of t. So therefore, ds by dt equals to 3 over 16. 16t minus 1/3 t cubed. Okay, times through by this. Integrate both sides. We get this. Okay, so therefore we get S, which is what we're trying to find, right? Equation for S in terms of t of 3 over 16. The integral of this will be, 16 t squared over 2 minus 1/3 t4 over 4, which gives us 3 over 16. This will be of, did I make a mistake? What have I done here? 3 over 16, this is not 16. Acceleration equals 16 minus 2. Okay, so this equals to 8. What have I done wrong? I haven't done anything wrong. Okay, sorry about this. I'm going to redo this bit here. Not on point today, boys and girls, but that's all right. I'm going to simplify. I don't have to do this, but I realized that if I do it that way, it's going to be harder. It's going to take longer. I'm going to simplify this. 16 and 16 will cancel to get 3t, and then these will cancel to get minus 1 over 16 t cubed. Right? So therefore, ds by dt equals to 3t minus 1 over 16 t cubed. So ds times this, dt, integral. This becomes s, so therefore we get s equals to, this integrated will be 3t squared over 2 minus 1 over 16 t cubed over, up 1/2 over 4, not between anywhere, plus a new constant, let's call it d. And so let's simplify this even more. We get 3 over 2 t squared minus, well, this would be what, 1 over 64 t4 plus d, and d will be 0 because, you know, the displacement is from our starting point O. So when s equals 0, t will equal 0. And so, 0, 0, so we'll get d equal to 0. So d equals 0. So then we get this, but it wanted it in the form of this. So we just drop this off to the side. T squared of 96 minus t squared. So we want to make this look like this. So therefore we get s equals, let's take out 1 over 64 t squared. This will give us, well, 3 over 2 times 96. 1 over 64 times 96 gives us 3 over 2. So this would be 96 minus 1 over 64 would be t squared, which is what they have here. That was a little bit of a shambles, but it's all right. Let's continue. So B, find the speed of P at the instant that it returns to O. So let's recall what we have. We have V equals, where's our V? We have V equals to this. I'm just going to put a star here. So let's just rewrite that. 3t minus 1 over 16t cubed. V equals to 3t minus 1 over 16t cubed. And we also have s equals to 1 over 64 t squared of 96 minus t squared. Okay, and so it wants to know what the speed of P is the instant it returns to O. So it's starting position. So when s equals 0, what is the speed? Well, when s equals 0, this becomes, so we want to find the time at which it arrives back at O, so then we can substitute it back into here and find the speed at which it, what it has when it re-arrives at O. Starts at O, comes back to O. Equals 1 over 64 t squared of 96 minus t squared. So this occurs when t equals 0, right? And obviously, it's at when t equals 0, s equals 0. Starts at times 0 from displacement 0. And t equals to, well, 96 minus t squared equals to 0. So we get t squared equals to 96. So t equals to the square root of 96, which could be written as the square root of 16 times 6. I'm just trying to get it into a surd form. Times, so this would be what? Square root 16 times square root 6, which is 4 square root 6. So at time equals 4 square root 6, it returns to O. So its displacement's at 0. So therefore, the velocity at time equals this will be 3, 4 square root 6 minus 1 over 16 of t cubed, which is 4 square root 6 cubed, which will equal to 12 of square root 6 minus, this will be 1 over 16 of 4 square root 6 times 4 square root 6 will be 96. So this would be 96 times 4 square root 6. So 96 divided by 16 is 6 times 4 is 24. So this would be 12 square root 6 minus 24 square root 6, which equals minus 12 square root 6. So the velocity will be, what is that? Well, minus 12 times square root 6 is minus 29.4 minus 29 meters per second. But that's the velocity, and it asks for the speed. So the speed when it returns to O is going to be 29.4 meters per second, right? And C, right, speed doesn't have direction, velocity does. Same with distance, doesn't have direction, it's a magnitude, and displacement does. You can move you can have a negative displacement depending on where you start. Find the maximum displacement of the particle from O. So this is from, the maximum, so max S will occur when ds by dt equals 0. and s equals to 164, 1 over 64 t squared of 96 minus t squared. Let's expand that because I know I'm going to have to differentiate. I'm going to expand this out. That's 3 over 2 t squared minus 1 over 64 t4, right? 96 divided by 64. Yep. Okay, so therefore ds by dt equals 2 times down by 2 gives us 3t, and this would be times down by 4, so 4 over 64 is 1 over 16, so minus 1 over 16 t3 equals 0. Where does this equal 0? Well, t, let's factor out a 3t, or let's divide 3 by 3, we get t minus 1 over 16 divided by 3, 1 over 48. 1 over 48 t cubed equals 0. Factor out a t squared equals 0. Okay, so it occurs when t equals 0, which kind of makes sense, right? Because it's going all the way and then coming back. So it's like yeah, but it's not going to be that. But when 1 minus 1 over 48 t squared equals 0. So this is going to equal 2 t squared equals 48. So t equals the square root of 48. Again, I could do that as well. Square root of 16 times 3. Brain. Times 3. So this equals to the square root of, this equals to 4 square root 3. Feeling tired today. Okay. So therefore S max occurs at time this. So it's going to equal to 1 over 64. 1 over 64 of 4 square root 3 squared of 96 minus 4 square root 3 squared. So these are t squared, so it's actually 48. So this equals 1 over 64 times 48 of 96 minus 48, which equals 48, right? That's 48. So it'd be 1 over 64 times 48 squared. Squared divided by 96 is 20. Wait. 96 minus 48 times 48 divided by 90 divided by 64 is 36 meters. So therefore the maximum displacement of the particle is 36 meters. Okay, hopefully that was useful. Sorry for the few mistakes that I made, but I went through 2 good examples there. You have that worksheet, which is really good. It took me ages to make, where you've got all of them, and they always ask this question, and it's pretty similar every year, so it'd be pretty easy for you to get these marks. Okay, and now I'm going to explore the idea of change. Okay, right, I'm going to be introducing you to a idea which, if understood well, will transform your entire life. And that is the idea of change. We looked with this video into the idea of things changing, a rate of change, velocity, displacement. These are changing. We're selecting variables in the world, and we're observing how they change and saying that that's predictable and can change through mathematical equations. But what I want to do right now is I want to talk about this idea of change and how powerful it is. What's happening is you are explaining away reality through logic and through things that you've been sort of that have been ingrained in your mind, that everything around you is changing all the time, right? Constantly. The world is impermanent. The universe is impermanent, which means it never stays the same. It's constantly evolving, constantly changing. You are constantly changing as well. And every day when you walk through the world, this doesn't seem, I'm assuming, to be that significant to you or peculiar, that everything around you is constantly moving and changing. And let's say, for example, you were the first human being on Earth. You came into this experience and you didn't know any of the things you know. You would be sitting in a complete mystery. You would be absolutely baffled by what's going on around you because you're not unconsciously explaining it all away. And you have these things where you're explaining it away, so it makes the world seem like understood by you. But if you start to remove that and think about what would it be like if I just turned up here, you would be absolutely gobsmacked. You would be like submerged in complete mystery. Everything would be so peculiar and beautiful and interesting. You'd be like a child again. You'd be like, I don't know what's going on. And sort of what happens with science and math and these things, they have logical, concrete explanations for what change is, because that's basically what we're describing, how things change. And it makes it seem like the universe is almost mundane and logical and works sort of like a clock. It's very mechanical, where in fact it might not be. And I want to open your mind up to that possibility that if you were the first human here, you would be baffled. You'd be like, what is going on? Your eyes would be open, and yet that's not happening for you. And the reason that's not happening for you on a day-to-day basis, you're not seeing the beauty and the mystery and the complexity of the universe, is because this has been ingrained in your mind, so it makes reality seem solid and predictable. That's the power of these ideas which have been presented to you, is that it's actually changing your experience. And really what I want to say here is, in fact, if you understand this idea, that I'm not just talking about changes in the environment and the external world. I'm not just discussing that. I'm also discussing the change which occur within you, the changes that occur within you as you progress through life. You will change. And if you don't change in ways in which you sort of want, then your life and the experience of your life will go in a direction which you don't want. And I will pose to you that, in fact, people who don't change and evolve themselves through intellectual understanding, through new experiences, through all these things, then it makes their experience very mundane and boring, and they become depressed, and they lack that awe, they lack that spirit, and it almost destroys their soul. And so change is very vital. And the change which you experience within yourself, which kind of separates you from the inanimate objects, is that you can consciously change yourself. Whereas it seems like the external world can't. It's predictable, whereas you have control over your change, which separates you from the change discussed in the mechanics that we just did a video on. This change. And so if you change yourself, maybe the world will change too. Let's say, for example, you become more open, you become more loving, you see more beauty in yourself. I will say to you, well, maybe if you do that, then the universe will become more open, more loving, and more beautiful. If you find more mystery within yourself, then there will be change within your world which you experience, and it will become more intriguing to you. You become more creative. There's so many things that can come from change. The change within you is related to the change of the world, of your experience of the world. And this is a very important dynamic in which, if you understand this, it will change your life. And so I would highly recommend for you to contemplate what is change externally, and what is change internally, and how can I change to produce a life which is more fruitful for me. And I just wanted to say that and give you a bit of inspiration. So the ideas that we're finding and we're trying to describe within physics or mechanics here, and we're presented with this idea of change. This idea of change is actually integral and important to your own life. And it plays a huge role. It's not just some crazy external idea, it's highly integrated into your own existence. And so that's it. And yeah, just a different take on it, just to try and inspire you a bit. But that's all. Please like and subscribe, and I will see you later.